Yeah, the paper class today I have not still dispatched. I'll let you know about that later. But anyways, for now, maintain a writing book. Then after you get the tutor also, you'll be getting all the questions. So you have to always have your writing book where you write your answers. What did you do for them to say congratulations? Did you crack any big company code? No, I got 100 plus A's followers. The 2024 batch has produced what do you call more than 100 A's. Didn't you check the channel? Yes. Okay, let me on the timer as well. I will be sending the tune. Okay. And yeah, I was actually putting on the recording. That's why the screen was stopped. Start doing the sixth question, all of you. Let me put this a bit up and down. And let me cover the. Okay, start doing the sixth question, all of you. Once you're done, raise your hands up in Zoom. Yes, thank you. So our numbers have to change to even, right? Let me check the question. The flowchart given is displaying the odd numbers in a range. X equals 2, display x equals x plus 2. Yeah, that should be even because 2 is an even number. So this has to be even in a range. Write down the first three outputs and the last three outputs of it. Okay, perfect. Do that correction. How to rearrange the flowchart if you want to display all even numbers from 1 to okay, that's correct. Now I can see the screen, right? Walaikum salam. I'm going to send the next tute. Yeah, I'll be sending it. Still, you will be getting it soon, don't worry. Actually, you have your second lesson tute is already dispatched. It was dispatched this week. And the problem is there's some strike in the post office, it seems, head office. So there's a small delay in the tute scheme they were saying. Let's see. Thank you. Thank you. I'll let you all know about that. Still, it's not properly packed. There's a file that's been delayed. I mean, delayed. Once I get the file, it's perfect. I'll let you know about it. Yes, Papa. Start doing this question all across the sixth question. Once you're done answering the sixth question, so make sure you write the question number six, just like paper class, and just like question number six, and start mentioning your answers there. Once you're done, raise your hands up in Zoom. Can you share the PDF of the paper? Actually, I have it's the same paper that last week's paper. It's there in the WhatsApp community. Those who are there in the WhatsApp, the paper WhatsApp community, I'll share the link of it in the chat. So give me a moment. Copy link. Copy. So those who are not in the paper class WhatsApp community, join there because I normally post the unfilled PDF as well. Why didn't I have the paper class last week? This is the same background that as well. But the next batch is ours. So inshallah we'll be five batches. Inshallah, inshallah. Inshallah, let's see. Thank you. Can you repeat the previous one? What do you mean? The week before the last. Maybe. Cool. You'll have 30 seconds more. Okay, let's start. Last one, it's odd. It's even. Because let's see. No, by default, it's showing all the even numbers from 0 to 100. No? So it should be odd. Because if it's even, then there's nothing to do in the question. So yeah, it has to be odd. Exactly, it has to be odd. Okay, your time is up. And at the moment, six of you are done. Is there anyone of you who wants some more time to do this question? How long do you need? 2 minutes? Okay, I'll give 2 more minutes. Those who are still doing the question, quickly finish it off. What do you called? Wait, I put a 5 minutes timer. I'll give 5 more minutes then. I thought I put a 10 minutes timer. Sorry, my bad. You're joining today. Okay, good. That's fine. Just try doing this question with the what do you call knowledge you'll have. And once we start discussing, you will be able to what do you call grasp the idea. So as usual, make sure you maintain a separate writing book for the paper class. And in that separate writing book, make sure you record all of these steps. Do the sixth question, all of you. What are we doing? So technically, how the paper class works is I'll be screenshotting a question. I'll be actually printing this thing later, but yeah, for now I'll be screenshotting the questions. And you'll have to maintain a separate book for paper class, a writing book. And just write down the question number and start writing your answers there. So once the timer is over, I'll start discussing these questions and you can correct your answers. And apart from giving the answer, I'll also be giving you all the background knowledge. I'll be doing some teachings as well. So if you feel like, okay, there's some important notes which you can actually note down, then you can note down those notes in your writing book as well. So yeah, start answering this question. Roman number 3 should be redraw the flow chart. It's not, no, you don't have to redraw the flow chart. You can just mention in a bullet point what is the change to be done. Like there's some change you have to do. If you do that change, it will show the odd numbers, right? So yeah, not necessary, Hannah. Better if you can, but not necessary. You change the place actually. Yeah, change the place. Basically, this was the old place. That new place was a temporary place. I don't notice that. Apart from your answers, you will teach the background. That's why we done. Nice. Those who are done, raise your hands up in Zoom. Huh? Good job. What they mean by output is if the condition is true, what is the output, right? Not exactly. In a program, when you say output, you can find other program outputs in statements like if they have used the word called output, or if they have used the word called display, or if they have used the word called show, or as write. These are keywords used to output something in a program. So if they say display X, that means, sorry, if they say display name, so name is going to get display. If they say display one is going to get display, something like that. Yes, sure. Imad this WhatsApp to the this number. Mention that you will not be coming to the Corona class. So what is algorithm? Can we write it as a step for there's one word you're missing Rishta. But to add that one more word, your answer is correct. It was award screen and I got an award for ICT first place for the last year performance. Good job. For that, what did you do the last time? You told something, right? Okay, your time is up. Let's check your answers, all of y'all. Ta-dun, 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 ta-dun. Okay, so this was a question I gave you to do. Let's check your answer. So in this question, they have mentioned that algorithm can be used to write the programs easily. Okay, what is an algorithm and what are the types of algorithm? Perfect. I'll just write my answers here because it's very scattered there and submit there. So yeah, sixth question, 1A. Yeah, 1 and 2. So what do you call like that? Good. So normally, what do you call if you take programs or else applications, right? You have WhatsApp, Viber, Instagram, Facebook, Zoom. These all programs, right? You can call them as programs, apps. So normally these programs or apps, they're actually made, or else the process of making it, we call this developing it. Okay. So they're actually made or is developed by a person called as a developer. Okay, these programs or app, they're actually made by a person called as a software developer. So even though developer is a person who makes the application, he does know how to code. His knowledge is very good to how code. Code is basically a process of creating the application. Okay, he just knows how to create the application, but in terms of giving the idea of what to create, he's not there in his hand. Okay, he doesn't have a big idea of what to create. So I'll tell you a real world scenario of like how are these apps actually born? Like how is the birth of application? I'll just tell you from the beginning process. Just have a small attention here. So if you go back, if you take a application or it's a app or whatever, normally there will be a person who actually has an idea. He's a person who has idea and he'll be like, hey, I have idea to make an app like this. Okay. Some people you can call it as idea. or in certain scenarios, you can call it as a problem. Normally, an idea will be referring to a problem. Like, for example, if you take WhatsApp, the idea of WhatsApp is okay, let's make a chat application. The person who created WhatsApp, his main idea would be okay, let's create a chat application. And if you look at okay, what is the problem he's addressing? He's addressing a problem of where people can communicate efficiently or people unable to communicate efficiently using internet. So okay, it's very hard to communicate using it because back then they mainly we were using emails. Back then earlier we were mainly using emails. If you're going to use internet to communicate, and internet is not very user email is not very user friendly. So they were like, okay, let's make a chat application that's very user friendly and can be used to communicate with friends and family very easy. So that was a problem he's addressing. So always an idea will always reflect a problem you're going to solve, right? So initially, when you take what do you call app or a program or whatever, there will be a person with the idea. I can call him, let's say, our client, our customer. Okay, the client or else customer. So let's say there is a customer, he comes to me. Okay, now let's say I have a software development company. Okay, so my client will come to me and he'll be like, okay, what do you call? I have a small problem. I want to create application. I want to create a program, and this is my program requirement. Blah blah blah. He'll come in. He's coming to me and telling he wants application. Now, if you take my development company, what do you call? There are obviously in the development company there will be several employees working. So there is like different teams of people. There might be finance team, there might be the development team. Rather, there'll be multiple teams. There'll be one team called the system analyst or else a business analyst. You can call them as a system analyst, or else you can also call them as a business analyst or software analyst, all the same. Okay. So what this team will do is this team will talk with the client, which means they'll talk with the customer. And by talking with the customer, they will be able to understand what are their requirements, what do you call, what type of application they want, killer. They will talk with the client or else customer and figure out all those requirements. So once they know the requirement, now they will pass this requirement to the software development team. So in the software development team, the person who is going to make the application, we call that person a software developer, right? Now there is one thing. If you look at the client and customer, between them there will be like a conversation, and they will be jotting down what type of system they want. So the idea of what we are going to create, okay, like what we are going to create is going to be decided by the business analyst team. Okay, they'll tell, okay, let's make application that looks like this, that has let's make a website that has 4 pages. In this page let's do this, in that page let's do that. They will talk with the client, and they'll both of them will come to a common ground. Once they come to a common ground, now they have to explain their idea to the developer. If they go and jabber the whole thing for the developer, that will be confused, because the software developer, he is not a very intelligent person. Intelligent means he will not have a big idea of common sense, like how it should, like how things should work. Sometimes he will not have a deep idea. So normally we have to spoon feed the software developer on how to make things. Like imagine something like this. Imagine at home you have your, let's take you all, okay? Let's say you want to cook some food. Okay, let's say you want to cook some food. Now you know to cook the basic foods. Let's say you know to cook rice and curry. You know to cook, let's say, what do you call fried rice, yellow rice, biryani. You know to cook all these stuffs, the basic stuffs. Normally the fun stuffs you know to cook. Now let's say you want to start cooking what do you call something new. Let's say you want to try this new dish. Okay, there is one person is coming in and there is a new dish like this. What do you call? Do you know how to cook, killer? You know to cook stuffs, but this is a new dish. You don't know how to cook. So for example, you're gonna ask that person, how to cook. Now imagine that fellow is coming in. It's very easy. Man, just add rice, just add the spices, and what do you call? Just keep it in the cook it and take it done. If someone comes and tell you an instruction like this, imagine you don't know to make a rice and curry. Let's come to y'all below. Let's say you all don't know to make rice and curry, or let's say you're like just how to make kottumi, and you all know how to make egg and fry egg. Let's say you all know only those two, and let's say you want to make rice and curry. So you're asking your mother how to make rice. If she comes and tell, just take rice, cook the rice. Cook the rice, add some spices, and the rice is ready, killer. Will you be able to achieve what you want? Will you be able to cook exactly what you want? If someone comes and tell you just like the background, they don't tell you how much to use. They don't tell what are the spices to use. They don't tell how much of rice to use. Okay. If they basically give you a slight just overview, okay. Simple. If they just give you the overview of all those stuff, you will be confused. Like, "Arey, how the hell should I know? How the hell do I know how to cook? You will be confused. Okay. So what happens is, do you know how to cook? Yes. Uh, Anyways, exactly. You will be actually confused if you listen to that. Exactly. You can go and ask Google ChatGPT. That's a different story. But if someone comes and gives the instruction on how to cook like that, like the way I told you a while ago, you will not be able to achieve what you want, right? So what when you want someone to cook something, so this developer is a person going to cook something, huh? The best thing you could do is you could give them a recipe. Now, you all have seen recipes to cook food, right? What will the recipe have? Recipe will have the ingredients. These are the things you have. A recipe will have the method. First of all, do this. Second, do this. Third, do this. Now, when you take a recipe, will a recipe have the things to be done? You can call the things step by step. Things are there to do, right? The methods. Will the recipe have those steps? Will the recipe have those instructions in a step? What do you call? How do you call sequential order? Sequential order means one after the other, step by step order. Will it have in a step by step order, or is the order random? Like, for example, there's a part called wash the rice, and then there's another part called, let's say, boil the rice, and there's another part called add salt. Will you first of all add salt to that uncooked rice, and then you will wash the rice, and third step will you boil the rice? Can you like that mix and do the steps? First of all, you take raw rice, take a salt, tikak dal, mix karla. After you wash the rice, remove all the salt, and then you boil the rice. If you follow the instructions like that, will you be able to cook rice properly? No, right? Exactly. So obviously, you take a recipe. Apart from we don't wash rice, right? Ade, go next time. Go home and see how your mom is cooking food. You have to wash the raw rice. Then only you can cook. There'll be dirt and dust and all those stuff. Anyways, what do you called? Yeah, coming back to the point, you can't mix steps. When you're following the steps, you have to make sure that you follow the steps precisely, step by step. You follow nothing, you will not be able to get what you want, right? So what happens is when you take these programs as well, when the system analyst or business analyst understands, okay, we need a chat application, we need something like this. When they're going to tell the developer, it's very difficult for them to tell everything like a paragraph. If they're going to give paragraph for developer, he'll not be able to do it precisely. Okay. So what we do is we like just like how you when you're going to cook, you get a recipe. Just like that, what we will do is we create something called as this system analyst, this team, this system analyst or business analyst team. What they will do is they will actually create something called as an algorithm. In companies to companies, it might vary. Some companies develop itself. There will be a development team who does it, but normally it's the business analyst who has to do it. Okay. So there will be an algorithm which will be made. So now let me tell you what this algorithm is. Algorithm is like your recipe, right? When you're opening a catering company, call us to be chef. This in short, I'll call. Anyways, but when you take algorithm, this algorithm will be like a recipe. What it will contain, it will first of all contain instructions. It's just instructions. Just like how your recipes have instruction, do this, do this, do this. It contains instruction. And if you're going to ask me in which order are these instructions written, these instructions are written in a step-by-step order. You can't go in a random order. You have to go always, follow the instructions. You have to go in a step-by-step order. And there's another name for step-by-step order. You can also call this a sequential order. Both means the same. Okay. And following these instructions, I mean, what do you call the algorithms? The instructions are written for in algorithm. There will be obviously a purpose. No. So the purpose these instructions are written is obviously to solve a problem. So, for example, if you go and take a recipe to what do you call make tea, that whole recipe contains instruction, and what is the purpose of that recipe is to make tea. You can't go and make plain tea with that recipe because the ingredients, the amount of tea leaves you might use for tea and plain tea is different. It's not just the milk difference, even the amount of tea leaves is going to be different, right? So for every what do you call problem, there is different recipes. Similarly, for every program, for every problem, there's going to be a different algorithm we are going to create. So technically, algorithm contains instructions. It is written in a step-by-step order. And why is it written? To solve a problem. This is how you can define an algorithm. So you put them together, you can say an algorithm is basically a step-by-step instructions written to solve a problem. Is that clear, all of you? Not plan, it's instruction. So the keywords here is these are the keywords, step-by-step instruction, solve a problem. So if you have written these three keywords, I'm not going to give the marks for the exam. I'm going to give my own marks. So in my answer, your answer has to be, it's the step-by-step instructions written to solve a problem. If you had mentioned the word instructions, you get 1 mark. If you had mentioned the part called step by step or sequential order or sequential instructions, then 1 mark. And if you are written to solve a problem, 1 mark. So total 3 marks for that question. It is a step by step instruction written to solve a problem. It is not a process. It is an instruction. So no, process is not correct. Plan, no. I wrote a set of instructions. Set of instructions, then you get only 1 mark. If you only step with instruction, 1 mark. Set of instructions, solve a problem, then 2 marks. Can we write for a given problem? Yeah. Set of instruction given to computer to perform a specific task. Wrong. Algorithm is not given for a computer. Now, for example, at the end of the day, when you take recipe, do you go and does your mother, if she's going to cook, she's going to follow a recipe and cook? Will she come and give the recipe to you? No. You don't give the recipe. No, let's say let's say you're having a hotel. You don't go and give the recipe to a customer, man. The recipe is given for the chef. Algorithm is given for the developer, not for the what do you call customer. The customer is not going to look at the algorithm. The customer is going to look at the program you make, the food you make. To make the food, you need the recipe. So the customer is going to eat the food, not the recipe. They don't care about the recipe. It's a method to show this. It's a method to show the steps in a solving problem. Wrong. 0 marks. Even though your answer has a part called steps, even though your answer is solve a problem, you get 0 marks because it is not a method to show the steps. Method to show the steps is only pseudocode and flowchart. What about a set of instructions given to perform a certain task? 2 marks. You have to mention the order of how the odd steps are written. Set of instructions to follow when doing a certain task. 1 mark. Maybe. By knowing that, what are you going to do, Swain? Because if you get or don't get it, that's not going to be relevant for this class. What's the exact answer? The exact answer is it is a step-by-step instructions written to solve a problem. An algorithm is the set of the step-by-step instructions is the step-by-step instructions written to solve the problem. No, set of instructions being to follow task. No. The sequence of finding solution to a problem. The sequence of finding a solution to a problem. At the part called sequence of instructions, but you get only 2 marks. Okay, let's correct. Yes, as a software developer similar to software engineer. Software engineer is a field. It's like you're asking me, is ICT teacher, maths teacher, is it equal to teacher? All of them are teachers, but you don't call them as a teacher. You call them an ICT teacher, maths teacher. Software engineer is a field. It's not a work job. The step-by-step instruction written to solve a problem is full marks. Okay, so that's the answer for the first question. The second question, what are the types of algorithm? So when they're referring to what are the types of algorithm, they're basically talking about how can you represent the algorithm. Okay. So normally in writing the algorithm, you can represent the algorithm in 2 different ways. I answered your question. Instructions to follow when doing a certain task. I told no. Look at your answer. Do you have the word called instruction in your answer? Yes, 1 mark. Do you have the part called step by step? Do I have any other synonyms giving that idea? No, so you don't get that marks. Have you mentioned that you're solving a problem by looking at this instruction? Or is this instruction written as a solution for a problem? No, right? So you'll be getting only 1 mark. Simple. I so these are 3 keywords. Your answer has to highlight these 3 points. That's how the marks are broken down. Okay, yeah. Second question. So when they say what do you call the types of algorithm? Okay, there are referring here to how you can represent the algorithm or how you can draw an algorithm or how you can write an algorithm. So normally when you're representing algorithm or when you're creating an algorithm, there are several ways you can create algorithm, but There are two common methods which we have learned in our syllabus, but even though we have learned only two, in reality, there are more. Okay. So when you want to represent an algorithm, the two main methods are, one is representing it only using just words like text, all step-by-step text, and there are certain keywords you might use. So we can call them as a textual representation. So there's a special name for this textual representation. We call this textual representation as something called as pseudocode. So pseudocode is actually the textual representation, which means where you have the algorithm just written using simple English words, and there are certain keywords used to, or there are certain respective words used to signify a specific instruction. So these are textual representation. It contains just text, just words, simple. Then there is another one called as a graphical representation. That graphical representation has a special name. We call that graphical representation as flowchart. So flowchart also has full of words only. But apart from words, flowcharts has certain what you call lines as well as shapes which we use. Okay, so because we use certain shapes, because we use certain lines, all those stuffs, the graphical representation of an algorithm, we call that as a flow chart. So these are the two ways you could represent an algorithm. So if you look at the question given here, the question has given you something called as a flow chart. So these are graphical representation. You can see apart from text, there are some shapes used and there are some lines used as well. Okay. So for that question, if you had mentioned pseudocode, you get 1 mark. If you had mentioned flowchart, you would have got 1 mark. If there's any other questions, drop in the chat. Next question. The B part. So in the B part, they have mentioned there, the flowchart given is displaying the even numbers in a range. Range means between a number to number. Okay. And they're asking you, write the first three outputs and last three outputs of it. Okay. Perfect. I wrote textual and graphical, 0 marks. Then what are repetition, sequence, and selection? They are actually called control structures. So control structure means how are the instructions followed when going through an algorithm. So when you take the algorithm, okay, algorithm contains instructions now. So how the instructions are followed, or what kind of instructions are there? What kind of instructions does it contain? So if it contains only instructions to be done one after the, just for example, do this, then do this, then do this, then do this killer. Let's say there's 4 instructions, just only 4 instructions, and all 4 has to be followed one after the other. It doesn't have to be all 4, but yeah, if the instructions has to be just only, you have something like this, just following instructions one after the other, it's sequence. But when you're following the instructions, let's say at a point, you're going to make a decision, you're going to make a choice. Like, for example, let's say you're going to make, what do you call, let's say you're going to make, give me an example to my head. Okay, let's say you're going to make something for the evening to drink. So let's say you're deciding, should I make tea or coffee? You're making a decision, should I make tea or coffee? And if you're going to make tea, then there's different set of instructions to follow. If you're going to make coffee, there's a different set of instructions to follow. So in sequence, if you're following the instructions, at a specific point, if you're going to make a decision or a choice, and depending on that decision or depending on that choice, if you're going to change directions, that we call a selection. We call these structures a selection structure. Then the third structure is repetition structure. So repetition structures are following instructions. And let's say at a point, due to a certain factor, you're going to again and again follow a specific instruction. Or again, they're going to follow a collection of instructions. That's how repetition works. Like, for example, let's say the instructions I'm going to give you to ask permission from your parents. Let's say you're going to go for a trip by your school and you ask permission of your parents. So go and ask the permission. If they say no, what you will do? You'll again go and ask, again go and ask. So that asking permission is going to again, you're going to go and ask permission. So that's that asking permission, that instruction is going to be followed more than one time. So if you have to follow an instruction more than one time again and again, that's the repetition structure. Repetition. So these are called control structure. The instructions we have inside a algorithm, how are they followed? Got it? So this answer also gave marks in school. That is wrong. That's not type of algorithm. There's just two types of algorithm. Simple. I wrote sorting, searching, graph. Eh? No, that doesn't have any connections with this. Those are control structures, not technically types of algorithm. When you say representation, how an algorithm? Now, for example, if you look at this is an algorithm. I mean, this is a type of when you say types of algorithm, this is a type of algorithm. Okay, if you ask what type is this, this is what you call textual type, a type that contains only as a graphical type. So when you say types of algorithm, they're mainly referring to the textual type and graphical type. Control structures only sequence, selection, repetition. Okay. Technically, that's invalid. Doesn't make sense. The flowchart given is displaying the even numbers in a range. Write the first three outputs and last three outputs. Okay, let me show you how you can figure out outputs in a program. Okay. Normally, the most efficient approach or the best approach I would tell is drawing something called as a dry run. Is the most suitable approach to actually figure out instruction, to actually figure out what do you call to actually figure out how the instructions are. Okay. Some of you all said what you called that your teachers were saying that sequence, selection, repetition. These are the types of algorithm, right? So imagine there's algorithm like this. Uh, this is for fun technically. Let me just take a random program and show you. If I was in your school, I'd go and argue with the teacher, man. I mean, there are certain programs that has repetition and sequence both. So repetition and selection both. Then that comes under what type? It's taking time to open. Why? Open quickly, man. When it loads, I'll tell you. 1 points to argue the teacher asked me. I'll give you. When I did a question in school using dry run, even my teacher was shocked because she didn't know it at all. Because dry run is nothing that's taught in O levels, dry run is nothing that's taught in A levels, and dry run is nothing that's taught in degree as well. To be honest, I don't know how I learned it. Anyways, what do you call let me show the dry run first. Okay. So what do you call yeah, to find the output of the program, it's actually dry. We are going to draw the dry run. So dry run is just like a table. It's not actually a table, but it looks like a table, but there is no correlations between column names. Keep that between. There is no connections between column names. So to draw the dry run, I'll show you what a dry run is first. But before you draw the dry run, there are things you have to figure out. First thing you have to figure out is what are the variables used in this program. Okay. Second thing to figure out is what are the conditions you can see in this program. Now, variables means like under a name, we are going to store values like that scenario. Like, for example, you can see under the word called X, or under this letter called X, we're going to store a value. We're saying X equals 2. So this is word called X, the letter called X to store a value. So when a letter or a word is going to store a value, in general, you can call them as variables, right? So you can find variables in a program in two places. One is if there is an instruction saying input something. Second thing is in equations, you can find variables. Like if you look at this algorithm, there is no input statements. Like they are not mentioned input X, or they have not mentioned get X, enter X. They have not mentioned input instructions. So there is no problem here. Second thing, if there is no input instructions, second thing you can do is again double check the variables, the equations as well. Equation means any instruction that has equal symbol. Or in a flowchart, very easy, a rectangle which has equal instruction. That's a rectangle which has a equal symbol. Okay. And if you look at this flowchart, here there is a rectangle, here there is a rectangle, and both these rectangle actually has a equal symbol. So what you do is you go to equations, and always in equation, tell me when you look at equation, if I say x equals 5, we are giving a value for x, or we are giving value for 5. For whom are we giving this value? The left-hand side person or right-hand side person? LHS or RHS? Take an equation, always we are giving a value for whom? The left-hand side or the right-hand side? Uh, value, let's say values or numbers or whatever. Exactly. Always when you take an equation, we are always giving a value for whatever we write in the left-hand side. Okay, perfect. Whatever we write in the left-hand side. So in this scenario, I'm giving a value for x. Okay, if you look at this equation called x equals 2, also I'm giving a value for x. If you look at this equation x equals x plus 2, for that also I'm giving a value for x. So go and see what are the unique words we are giving a value. So here also we are giving value for x. Here also we are giving value for x. So go through all the equations and figure out who are the people who are giving the values. So in this program, you can see only for x we are going to give a value. So x is a variable we can find out in this program. Conditions are like questions. In a flowchart, it's very easy to find out conditions. Always a rhombus will have a condition, like a question. So you can see there's a question here. We're going and asking the question, is x greater than 100? Okay. So always where you can go and see a condition, that's definitely going to be a but the equation. Okay, sorry, wherever you can see a question, that's definitely going to be a condition. So here we have the question, is x greater than 100? No. So I am figuring out that as a condition. So in this program, there's only one variable called x. There's only one variable. There's only one condition. Is x greater than 100? There's nothing else. So I'm going to draw like a table with one column for x, which means I'm going to have one column each for every variable in my program. In this program, only x is there. So I'm going to create one column for x. Then I'm going to have one column each for every condition. So in this program, there's only one condition. For that one condition, I'm going to have one column. Okay, again, I'll repeat. You're going to have one column each for every variable. You're going to have one column each for every condition. Now what you're going to do is write another extra column called output, and all the outputs right inside this column. So let me show you how you fill this table. So how we are going to fill this table is we are going to go through these instructions one by one. The first instruction we have is x equals 2. So I'm going to come and write on x, the value of x is 2. So we are going to store the values of the respective, what do you call, variable below it. The next instruction we have is display x. Display means we're asking to show the value of x, right? So currently you can see the value of x is 2. So I'm going to display 2. So display means output, no? I write that there. Do we need a column for x equals x plus 2? No, man, I told you we are going to take the variables. Is x equals x plus 2 a variable? No, that's an equation. I said you can go and find a variable in an equation. So in this equation, you just go for the left-hand side, we have x. In this equation, go for the left-hand side, you have x. So only x is a variable we have in this program. For every variable, we have a column, not for every condition. Right? So we wrote there the value that display x is done. So I'm done in the first condition. Instruction, I'm done in the second instruction. The next instruction I have there is x equals x plus 2. Okay. Again, I told you always an equation, we are giving a value for the left-hand side. So we're going to find the value of x now. So we are saying that is equal to x plus 2. Currently, if you go and look at the table, right, you can see in the table the value of x is 2. So when you say x plus 2, we are meaning 2 plus 2. So where did I get this 2? Is from this table. I got the value of x as 2. So I replace x to 2, and x plus 2 is 2 plus 2. So value of x is 4. So if you look at this equation, indirectly what this equation's meaning is, we are saying the new value of x is going to be equal to the current value of x plus 2. So currently you can see the value of x was 2. So current value of x plus 2 means 2 plus 2, and it becomes 4. So now what happens is the value of x is changing. Okay, because we are saying x is equal to this scalar. So we are changing the value of x. Earlier x was 2 and now x becomes 4. So I cut that and write here. The value of x becomes 4. Now I go for my next instruction. If I follow the arrow and go, the next instruction is this condition. In this condition, I'm asking, is the value of x greater than 100? Again, look at the table, x column, and look at the latest value of x. So always we look at the latest value of x. So currently, if you look at the x column, the latest value of x is 4. So if you go and look at 4, is 4 greater than 100? Yes or no? You say is x greater than 100? Currently, x is 4. So if I ask you, is 4 greater than 100? Yes or no? Is 4 greater than 100? Exactly. You all know? It's a simple question. It's actually a no, right? So I'm going to go and mention there no. For the condition, I'm going to go and mention, again, keep in mind, in a dry run, there is no connections between rows. So just because I wrote no here, that doesn't mean, okay, when I'm checking x is greater than 100, that doesn't mean I'm checking the value of 2. Currently, I'm actually checking the value of 4. That's why I told you, don't think that dry run has a connection between columns. They don't have a connection. These are like standalone column. Imagine this as 3 different tables. Okay, don't think it's one table, think this as 3 different tables. Okay. Anyways, now I go for the next instruction. Yes, you can write false as well. So because it's no, I'm going to go in this direction because you can see this direction is labeled using no. If I go in this direction, the instruction I have to follow is pointing here, which means I have to go like this, display X. So it's asking me display X. If you look at the table, always look, when you're looking at the table, look at the latest value. When you look at display X, ask me to display the value of X. So I go for the column X and I see the last value. The last value is 4, right? So I'm going to go and display 4. So earlier 2 got displayed, now 4 got displayed. Then I go for the next instruction. The next instruction is x is equal to x plus 2. Again, I told you when you say x equal to x plus 2, the meaning of that is the new value is equal to current value plus 2. So based on that, tell me, after I follow this instruction x equals x plus 2, what will be the new value now? Currently, you can see x is 4, right? So after I follow that instruction x equals x plus 2, what will be the new value of x? Perfect. The new value of x is going to be 6. So I'm going to go and change the value here. I'm saying the value of x is now 6. Till I go and mark it here. The next instruction we have is x greater than 100. X is now 6. If you go and check is 6 greater than 100, again, that's going to give you a no. And if you go to follow the instruction and go display x, it's going to display 6. So if you keep on filling the table, it has several records here. So because it has several records, I'll just quickly do it. Okay. So you display x. After you display x, you have x equals x plus 2. That becomes 8. Is 8 greater than 100? No. Display 8. After display, this becomes 10. And what do you call? Then that becomes, after you, this becomes 10. No. And display 10. Now I have got here the first 5 outputs. Okay. So if you look at this table, you can see there is a pattern. Okay. You can see there is a pattern. Now, if you are practically going to ask me, is it suitable to draw the dry run for the whole question? In this question, it's not suitable because this question has too many outputs because we are going to go up to 100. Imagine you're going to go up to 100. This will have around 50 rows. Average around 40, 50 rows are going to come here. It's going to take your time. So what you can do is you figure out the pattern. How is it going? How is it going? How is it going? You see the pattern. So if you look at the pattern, it went like this. First of all, the value of x increased. 1. Like if you look at what is repeating, what is repeating? First of all, the value of x increased. After the value of x increased, like I'm talking about what is, sorry, not first of all, value of x increased. First of all, actually, the value of 10 was displayed. Okay. After the value of 10 was displayed, second, you can see we increase the value of x. And third, we're checking that condition. The pattern it's going, the pattern we are going. Okay. So after every condition, after checking the condition, that how the pattern goes is we display x, we increase the value of x, and we check if x is greater than 100. So we know if you look at the pattern properly, you can see the value of x is going in the what you call multiples of 2, 2, 4, 6, 8, 10. So we know the last few ones would be, let's say, around 96, 98. That's how it's going to go. No? 96, 98, 100. That's how it's going to go. Okay. Now, if you look at the pattern properly, after the value of x is changed, that's the step number 2. Now, after it's increased only, we go and check the condition. Okay. After we increase only, we go and check the condition. Right. After we increase, first of all, we increase. After you increase, you actually wait. Before you display, we actually increase. After you, sorry, my bad. The order I said was wrong. First of all, you increase. Because here displaying is not showing the new number. Display is going to show the before increasing, right? So you can see display X is going to show before increasing. So the actual how actual order goes is, first of all, you increase the value. Then you check the condition. And if the condition is giving you no, then only you're going to go and display that increased value. Okay, again, I'll tell you, in this program, you can see there's the value of x is changing now, right? So initially, when the value of x was 2, okay, we displayed 2. Then we increase the value of x to 4. Even though we increase the value of x to 4, still we didn't display it. When do we display it? Only if this condition is giving us no. So you can see only if the condition gave us no, we're going to go and display the new value. Okay, so new value is going to see display X, we're again going to do only when value increases, right? So the correct pattern works is, first of all, you increase the value. After you increase the value, you go and check the condition. Only if the condition gives you no, you're going to go and display it. So this is 3. Okay. Now let's say the value of x became 98. You increase the value of x. So let's say value of x became 98. After value of x becomes 98, okay, let's say you go and check that condition. We went and check the condition is 98 greater than 100. When you go and check is 98 greater than 100, will that give you yes or no? When you go and check is 98 greater than 100, will that give you yes or no? Exactly. Okay. That'll give you a no. Perfect. That's going to give you a no. So because that's going to give you a no, yes, perfect. So because that's going to give you a no, you're going to go towards this right side direction, go up and display X. Okay. So because this gave you a no, you're going to display X. So 98 is going to get displayed. After you display 98, you can see next instruction is to increase the value of X. So let's say now the value of X has become 100. Okay. Let's say now the value of X has become 100. Now, after the value of X becomes 100, again, what happens? You're going to go and check the condition here is X greater than 100. When you go and check is 100 greater than 100, yes or no? When you go and check is 100 greater than 100, yes or no? Exactly. When you go and check is 100 more than 100, no, right? Imagine you have 100 rupees, your friend has 100 rupees. If I come and ask, do you have more than your friend? No, you all don't have more. You don't have more. You both have equal amount, right? So it is not more. So if I come and ask, do you have more money? No, you don't have more money, right? So your answer is again a no. Okay. So after your answer is no, when I ask is X greater than 100, if it's no, you're again going to go and display X. So you go and display 100. So after you display 100, now again, if you look at the pattern, after you display X, the next instruction X equals X plus 2. So X is going to become now 102. After X becomes 102, again, you're going to follow this condition and check is X greater than 100. So now if you go and check is 102 greater than 100, yes or no? Is 102 greater than 100? Perfect. When you go and check is 102 greater than 100, that's going to give you yes. So based on the flow chart, tell me, if that condition gives you yes, should you go the right or down? If that condition gave you yes, should you go to the right or should you go down? Exactly. You have to go down. So if you go down, now you can see the program has ended. If you go down, you can see the program has ended. Now tell me, before the program ended, even no, before the program ended, the value of x was 102. Okay, before the program ended, the value of x was 102. But did we display this 102? Did this 102 get displayed, even though that was the last value of x? Did we display that 102? No, we didn't display that 102. So if you look at the outputs here, right? Okay, if you look at the outputs here, the last output we had was 100. And before that, it was going in a sequential order 98, 96, 94. That's how the outputs were going. So like 2, 4, 6, 8, 10, 12, 14 kilo. The outputs were going in a sequential order. And the last output was 100. Okay, the last output is 100. So this question is asking, write the first three outputs and the last three outputs of it. The first three outputs were 246. These were the first three outputs. And the last three outputs were 96, 98, and 100. These were the last three outputs. So your answer has to be something like this. First three outputs, that's going to be 2, 4, 6. Last three outputs, that's going to be 96, 98, and 100. So for these now, most of the questions you all can actually draw the full dry run. But this question, it's not worth to draw the full dry run. So in the middle of the dry run, just figure out how the pattern, how the repetition is working, how is it repeating. And once you know the repetition order, just check with the last few values. Is that clear? Isn't the last one 102? Even though the value of x became 102, we didn't display it, right? Like for example, again look at the flow chart. Okay, again look at the flow chart. This is the instruction that made x become 102, right? This, right? This is the x equals x plus 2. That was the instruction where earlier x was 100, and we say x equals 100 plus 2, it became 102. So x became 102 in this instruction. Now, after this instruction, are we displaying that 102? No, this is where it became 102. But after it became 102 here, are we displaying that 102? No. Why? We went to this condition, and in this condition, we're going to check is x greater than 100. So we're going to go and check is 102 greater than 100. That gave a yes. Because it gave a yes, we ended the program. So from here to here, was there any part of your display in the 102? No, right? Yeah, that's fine. But 2 is already mentioned now. Is it wrong if you put 4, 6 as first three output? No. The question is asking when you run the program, what was the first three outputs? I showed you, right? 2 is getting output. So when the program executes, 2 gets displayed. So 2 has to be included. Is that clear? Can't we write like 2, 4? Can. So that can. If you mention like this also correct, if you all mention like this also correct, 2, 4, 6, dot, 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 comma 96, comma 98, comma 100, this is also correct. Anyways, if you had mentioned these three as the first three inputs, put 1 mark. If you had mentioned these three as the last three outputs, put 1 mark. If you had mentioned 102 as well, then no marks. Exactly 96, 98, 100. That's how the marks is broken down here. If you have any questions, drop in the chat. Write the pseudocode suitable for this flowchart. Okay, let's do. In pseudocode, the start we normally write as begin. So I'll write begin here. This is B2. In pseudocode start we normally write as begin. So I write begin here. Here we have x equals 2. In pseudocode also you can write x equals 2. So I'm writing x equals 2. The next instruction is display x. Again, in pseudocode also you can use display x. That's also fine. Then we have here x, what do you call x equals x plus 2. Okay, there's a small correction here. I will leave a space and write displays. I'll tell you why I kept the space later. So displays. The next instruction is x equals x plus 2. So I'm going to mention that instruction also as it is x equals x plus 2. Now the next instruction is x greater than 100. Okay. Now normally when you look at a condition, okay, when you look at a condition, the condition can represent even a repetition structure, because in repetition structures we use condition. A condition can represent a selection structure used as well. So if you were there in the previous paper class, in one of the classes, I can't remember exactly which week, I told you how to identify is it a repetition structure or selection structure. I'll again tell you now. Okay. So normally how you do is you go and check, when you're following the instructions, you have two paths. Okay. So when you follow these two paths, let's say there's one person going in this way and there's another person going this way. Both are going two different ways. Okay. One fellow is going in the yes direction and one fellow is going in the no direction. Okay. After each of them go in the two different directions, if they are able to meet at a point, if they can again meet anywhere common, okay, if they can again meet, not meet here in the beginning, I'm saying after they go in these two directions, if they can again meet, then it's a selection structure. If they don't meet, it's a repetition structure. That's how you figure out if it's selection or repetition. Okay. Now tell me, okay, tell me, let's say there's two people here. One fellow is going to go towards the no direction. He's always going to go in the no direction only. There's another fellow who's going to go in the yes direction. Are there any possibilities both of them will meet at a specific point? Yes or no? Is there any place they could meet after that, after they go in those two different directions? Hmm? Hmm? No, because why? If you go in this direction, you can see he'll go here. He'll follow these instructions, then he'll come in. He'll come to this point. After he comes to this point, he'll go to this point. After he comes to this point, he'll come to this condition. And after he comes to this condition, again he's going to go in the no direction, right? So he'll be, give me a moment, guys. Okay, so he'll be again that the blue fellow, he'll be again and again, the light blue fellow, he's going to again and again go in that right side, and he'll be rotating between this and these three conditions. So he'll be rotating again and again and again. There is no chance that he will go for the yes place. Right? Ignore about the condition, ignore about the value of the condition. Huh? I'm just saying if he's going to follow the lines, just the lines, forget about the values inside those. Okay? But if you look at the green fellow, at directly he'll go for the yes and halas, he's ended. Okay. So if one fellow is going to go in that, another fellow is going to go here, there is no place in a common place where they'll meet, right? So therefore, because there is no meetup, it's a repetition structure. So this is how you decide, is it a selection structure or is it a repetition structure? I can't remember what you call which recording, but one of the recordings I told this in detail. So I'm not going to again do it in detail. I just give a rough reminder now as well. Okay. So if you look at the repetition structure, now you have two types of repetition structure. One repetition structure is it will repeat if the condition is true. Another repetition structure is it will repeat when the condition is false. So normally if it's true when you're going to repeat, it's the while loop used. If it is false and we are going to repeat, it's a repeat until loop used. Now till here, in this question, the repetition is happening when the condition is true or when the condition is false. When the condition is what, does normally the repetition happens? What can you observe here? Exactly. You can see when the condition is false only, we're going to go and repeat all these instructions. And what are the instructions we're going to repeat? This, and this. These are three instructions. Actually, the third is a condition, but the display x and x equals x plus 2, Those are two conditions that's going to be repeated. So what I do is, because based on false we are repeating, we are going to put this inside a repeat until loop. So we are saying repeat display x and x equals x plus 2 until, what is the condition here? Until x is greater than 100. Okay. Until x is greater than 100. And yes, other program is. So this is how the pseudo code is going to look like. Now ask me your questions regarding this. Can we put x equal input x equals to after begin? No. There is a difference between an equation and an input statement. Input means we are asking the user to give a value. Equation means the program is giving a value. These are two different things. Input and x equals to is not an input. We're not asking the user to give a value. The program already predefines value. If you use while loop, if equals is wrong. If you're going to write the same program in while loop, you can write the same program in while loop, but if you're going to write in while loop, it's different. If you're going to write in while loop, the program will be like this. You're going to change the whole instructions. Begin x equals to the thing is, you maintain the logic. There is one place where this logic can go wrong. I will not. The correct while loop would be like this, but again, you're going to change stuffs. It's not called while do, or you go for do while loop, something like this. There is an issue in while loop, it will not give the exact result. Like, even though for this exam it will work, for all the exam it will not work. You have to twist the condition. In this, you mentioned while x is greater than 100, less than 100. This is one way of writing the while loop. There's another way of writing the while loop properly. Now, here I put do while loop, which means I have mentioned do first and then while. There's another way of mentioning the while loop as well, the usual way. If you're going to mention the usual way, there is one small problem. It will work only for this question. Because in repeat until loop, no matter whether the condition is giving you true or false, it doesn't care. The first time it will definitely display X. But while loop, that doesn't happen. While loop, that first come, first serve basis is not there. Okay. So therefore, doing this in a while loop is risky. But if you're going to do in a while loop first, the how the while loop would be. Begin x equals to while x is less than 100. No, wrong. While x is less than 100. While x is less than 100. Is 100 and 100 less than 100? No. Not while x is less than 100. While x is less than or equal to 100. Or else you have mentioned while x is less than 101. Nothing your program is wrong. Here also while x is less than 100, less than or equal to 100. Nothing you have mentioned while x is less than 101. So, or less than 102. So while x is less than 100, you can mention display x. Again, while loop is not suitable here. Technically, if I'm the teacher, I will not give marks for while loop here, even though I'll be getting the correct output. And while, and the reason I'm saying why while loop is not more suitable here is because in this program, no matter whether this condition gives you true or no matter whether the condition gives you false, in both the situation, like for the first true, the first time you're following instruction, no matter whether it gives you true or no matter whether it gives you false, still the value of x is displayed. 2 is displayed in both the situations. Okay. But in this, if you go in while loop, 2 is displayed only if this condition is true. So that is a small problem in this. Therefore, if you wrote this program, if I was your teacher marking the paper, I will not give you marks. Even though it's correct, even though it's reflecting the correct algorithm, this method is not suitable. In condition, why can't we use? But if condition, why can't? If condition is selection, man. This is not selection happens only one time. This is a repetition structure. If you start instead of begin, is it okay? It's okay, but depending on your teacher who is marking the paper, they might not give you marks. Because pseudocode flowchart, these are standards of writing, different standards. Now, for example, I'll show you a standard which we learn in school. If you go and see at these pseudocodes, you'll be like confused like here. This is how we write pseudocode. This is a different standard of writing pseudocode. If you were going to write pseudocode, like, this is completely different. No, if you go and write x equals 100. Like, you can't go and mention, let's say, what you call x equals 100. Let's say now, in your program, you directly go and mention child equals 0. But if you look at this program, you can't directly go and mention here the variable child equals 0. You write a word called set child to 0. You directly go and mention like input x scalar. Here you can't mention input x. Here to mention receive child from integer keyboard. Actually, when you want to display something, you can't just directly mention. Here be like send to display x. Send to display x. So these are different standards of writing algorithm. This is the Elixir computer science standard. But what I'm saying is you all have to follow the local syllabus, the normal pseudocode standard. So if you go and write in different standard, depending who is marking your paper, they will decide should I give marks or not. That's why I say pseudocode is one standard. Flowchart is one standard. In pseudocode, there are multiple standards. This is the Elixir standard. So if you go and write in this order, they will not give you marks. Simple. So just because it's correct, that doesn't mean you will get marks. Because you're not following the correct standard. For now, I'll give you marks, but in exam, don't mix the begin and start. Can you write in the while loop? I wrote it in the while loop. Yeah, I wrote them in while loop. Yeah. This is the correct way of writing the while loop. And this is a fine way, but I will not give marks for writing this way. This will give you the output correctly. But even though this gives the output correctly, it's not corresponding to how the algorithm works. What I mean by corresponding to how the algorithm works is one thing why the whole while loop is wrong is because both the while loops I'll be like not very happy with it because both have changed the condition. See, this is not the original condition we had in the program. We have changed the condition both. First thing. Second thing is in this program, only if this condition is true, the number 2 will get displayed. But in these two programs, even if that condition gave you false, still 2 will get displayed. The first value of x, the 2 will get displayed whatever the condition gives you. So therefore, I would not recommend you to mention this third answer, even though it's correct. So you get the marks for third answer only if your condition is correct. Huh? This is the most suitable answer. This is the answer that's like 1000% perfect. This is a perfect answer. If you know the first answer, that means you are giving the teacher the idea, okay, you have good knowledge about programming. The other answers it directly shows that you all don't have a good idea. This way is quite different from ours, isn't it hard? Obviously, it's hard. While is less than 102. While what is less than 102? You mentioned variable, you're going to check there. So you don't get marks there. Can't we say while x is less than 100? No. 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 You can't mention while x is less than 100. If you mention while x is less than 100, then what will happen is your program will not display 100. Because why? When you go and check the value, is 100 less than 100? That's going to give you false. So the display 100 will not display 100. Your program will display only 98. So if you mention display 100, your program is going to display only 98. Go and check your program. Draw the diagram. Can we put display x after writing until x is less than 100? Wrong. That will display a value. That will display only 100. That will display 102. If you write display x here after until, it will display only 102. The 2, 4, 6, 8, 10, it will not display. Why? Because after until is out of the repetition. These are the instructions that's going to repeat. So this display x will be repeated again and again. The 2, display 2, display 4, display 6 killer. The value of x will again and again repeat. But if you mention display x out of the until, it will get displayed only once, and only one value of x is going to get displayed. Technically 102, because when the program finished, so when the repetition structure finished, the value of x was 102. Got it, Shivsam? Set x equals to, that is not what you called local syllabus standard. That's it, Excel. Don't mention that in local. Anyone else having any questions regarding this? Why do we have to put, why do you have a repeat after x equals to? You mean before x? That's because for that you should actually go and study programming. Okay, there's two programming structures, pseudocode and flowchart. I actually told I will send you all these earlier. I didn't send you. I'll actually give it. I don't have the pseudocode of it. I think only flowchart I have it. I'll go and take. I did a seminar on programming. Let's see if I have that QT in my I don't have the pseudocode seminar to it, I guess. Only I didn't send it all because I don't have the pseudocode. But the flowchart, I think I have of the seminar we did. Yeah, but this has the pseudocode as well. There are two types of repetition structure. There are actually three types of repetition structures, but these are two main structures that is directly there. So you have the while loop, which is like this, and you have the repeat until loop, which is like this. Those are two types of repetition structures. If you don't know that, that means that shows that you don't have the programming part. You have to go and refer that. Anyways, I'll send that later. In the flowchart, it was x is greater than 100. Then why in the pseudocode it's x is less than 100? No, I told him these are the correct answer. The perfect answer is make you moment. But you call, I told these are perfect answer. See, the perfect answer is greater than 100. But if it, and I told you as well that if the condition is true and repetition is happening, it's while loop. If the condition is false and repetition is happening, it's repeat until loop. But in this program, you can say in the condition of false, the repetition happens. So definitely your user repeat until loop. But if you want to become a bit Araparichian without using repeat until loop, if you want to do the opposite, then if you're doing the opposite, the other way. So this is technically the not the correct way. But if you're doing in this way, then there are some modifications. Because while loop works and repetition repeat until loop works in two different ways. In repeat until, we do the repetition if the condition is false. In while loop, we do the repetition if the condition is true. So because if these two works in two different ways without modifying the condition, you can't expect the same result. Depends of mostly. Yes, Hassan said. Okay. So if you're I would not again I'm telling you, even though you have written these, if you are written using while loop, check if you are written like these two. For now, I'll give you marks, but if it was an exam, I would not prefer giving marks for those two structures because that's not the expected. So if you are written the pseudocode exactly like how I wrote, exactly, not even one difference, give 2 marks for pseudocode. Any of these, one of these three. For while loop, if you modify the conditions, the possible answers would be x is less than or equal to 100, x is less than 101, x is less than or equal to 101, x is less than 102. Apart from my condition, these are the alternative conditions you can use for while loop. Again, only while loop. Okay, next. Write how to rearrange the flowchart if you want to display the even numbers from 1 to 100. It's very easy. What should you do? What do you think I'll use? Let's see if any of you have a correct answer. Exactly. Your answer has to be very simple. It has to be replace x equals 2 to x equals 1 in the flowchart or in the algorithm. So if you replace that x equals 2 to x equals 1, it will give you all the odd numbers. Simple. So if you have written that part, replace x equals 2, what to replace to what? Both this has to mention. Huh? If you had mentioned what to replace and with whom to replace, you get 1 mark here. So check your marks, all of you, out of 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, out of 10 marks. I gave first question 3 marks, then 4, 5, then 6, 7, 8, 9, 10. Yes, out of 10 marks. How many marks I got? Replace the 2 with 1. Replace the 2 with 1. Here also there is 2, here also there is 2. So you will get 0 marks. X equals 2 to x equals 1. Correct. The word replace at that part. Huh? Make x equals 1. Wrong. Because here also you have x equals, here also you have x equals. There are two places you can say x equals. If you directly mention make x equals 1, that means you're asking to make both of these x equals to 1. And your answer is wrong. 0 marks. Change the value of x equals 1 instead of x equals 2. Change the value 2. Cut the word called off and make it 2. X equals 1, X is greater than or equal to 100. No, that part greater than or equal to 100 is not enough, not needed. Actually, if you mention greater than or equal to 100, doesn't make a difference. So school papers are not exactly sure. What is the third one's answer? Third one's answer is this here. Replace x equals 2 to x equals 1 in the program. Wait. Why avasaram then? What should I cut? I didn't get it. You have mentioned change the value of x equals 1 instead of x equals 2. Not change the value of x equals 1. You have mentioned change the value to x equals 1. Grammatical error that's. Other word could often make it 2. Change the x equals 2 to x equals 1. Correct. Um, change the value of x to 0. Change the value of x to 1. That's wrong. 0 marks. If you just mention change the value of x to 1, that's 0 marks. You have to be more precise with your answer. Here you go. It's okay. Yes, Sandra. Ibrahim, what's up? The Master IT hotline on. Okay. Actually, with that, we're done for the day because it's 6 o'clock. I want to do more questions, but yeah. If you have any questions, I can stay and ask. Others I can leave. If I did not answer your question, stay. Yeah? Others I can leave. Can we replace x mod 2 equals 0? X mod 2 equals 1. Where can you see this program is x mod 2 mean? I can't see the word modules in this program, so no marks. What is the answer for the last one? The last one's answer is replace x equals 2 to x equals 1. See here, I mentioned it. Number 3 answer. How much for the pseudocode? 10 marks. This pseudocode, 2 marks. Yeah. Exactly if you wrote one of these three answers. Exactly. Is this? Yeah, but it was not the oral paper, right? Some school paper. Do you have any advice on improving in pseudocode and Pascal? Don't focus on Pascal now. Improve your pseudocode knowledge. You can see in this programming question, there was nothing about Pascal, right? So don't think much about Pascal. I mean, you don't, not that I'm asking you to ignore Pascal. Give second priority for Pascal. Just go to YouTube. In YouTube, there was a full pseudocode flowchart covering semi-edit. There's around 8 hours recording, I guess. So go to YouTube and search for Master IT. So once you search for Master, you'll be getting this yellow color channel. When you click on this, there's an option here called lesson-based seminars. So under lesson-based seminar, you can see this scroll to the right. You can see introduction to programming. There are two recordings. I think first recording covers everything about pseudocode. Second recording covers flowchart and certain questions. I'm not exactly sure. Just to watch these two whole recordings, you can get a full idea about programming. Full. From scratch, I've mentioned everything. What is it as? If we change 100 to 110, no. 110 will give you wrong results. It will not give you from 1 to 100. Like, it will give more than 100 as well. It's actually good as just go and check. You can get a free trial session from the admin. Can we replace x mod 2 equals 1? Where do you see x mod 2, man? I don't see any x mod 2. So replace means remove something and put something. That's what replace is, right? If I say replace, what do you call your blue pen to black pen? I should take your blue pen and give you a black pen. If you don't have blue pen, how can I replace it? So there is no mod used. Where are you going to replace? Anyone having any other questions? Yeah, just join and see us. You can go for a fish and then see. Okay, as there was no other questions, I'm going to end the meeting. But again, if there's anything, drop me a WhatsApp message. WhatsApp to this number. If I have not replied any of your numbers, that's because these days we are getting the results. So I am just replying only the older 24 contacts. I have kept yours paused means that's means because I am collecting the results at the moment. I hope you all know there's more than 100 days we got this time for ICT from our students. So yeah, I'll get back to you also. Anyways, have a nice day. Bye bye.